Hi, my name is Dr. Michael Batu, and for this video, what I'm going to do is we're going to derive the equilibrium national income. So we know that aggregate expenditure is just the sum of consumption expenditures in the economy and investment expenditures. And we know that consumption expenditure is given by the aggregate consumption function, C sub 0 plus by. So autonomous consumption is C sub 0, B is our marginal propensity to consume, and we assume that disposable income equals to Y over there. And from the previous video, we assume that I, or investment, is autonomous, is given by I equals I sub 0. So what we're going to do is the following. We're going to write an expression for the aggregate expenditure, and we're going to solve for equilibrium national income. So if you recall from the previous video that AE is simply C sub 0 plus BY plus I sub 0, or AE equals to C sub 0, I sub 0 plus BY. Note that this B takes a new form. It's called the marginal propensity to spend. All right. What we're going to do next is we're going to graph this aggregate expenditure function, and we're going to find the equilibrium national income. All right, so there you have it. So that's the graph for our aggregate expenditure. Now the question becomes, how do we solve, or how do we find the equilibrium national income? Well, what happens in equilibrium is the following. So in equilibrium, aggregate expenditures equals national income. And this is an important condition. And mathematically, it's given by the following. Y equals to AE. That's the equilibrium. So if Y equals AE, okay, if we use this condition, equilibrium condition, and look at our graph right here, Y equals AE only occurs at the 45-degree line. So let's sketch a 45-degree line right here. So at the 45-degree line, Y is equal to AE. So at all points in this line right here, national income equals aggregate expenditure. And the 45-degree line crosses the aggregate expenditure here. And I will call this AE star, which indicates our equilibrium, aggregate expenditure. And here we have Y star, which indicates our equilibrium national income. Now, this is how you do it, or how you find your aggregate expenditure by way of a graph. How do you do it using math? Well, we know that our AE is given by this expression right here. So using math, we know that AE is equal to C sub 0 plus I sub 0 plus Y. We know that in equilibrium, Y equals AE. So all we need to do is just to sub this condition right here. So we have here Y is equal to C sub 0 plus I sub 0 plus BY. 1 minus B times Y. So I move my B to the other side. Okay, let me do that slowly. So it's going to be Y minus BY is equal to C sub 0 plus I sub 0. I factor out the Y. So I have here 1 minus B times Y, C sub 0 plus I sub 0. And finally, if I divide both sides by 1 minus B, I have here my Y star, which is I sub 0, C sub 0 plus I sub 0 over 1 minus B. Now, I can also express this way. Y star is equal to 1 over 1 minus B times C sub 0 plus I sub 0. So remember, our C sub 0 plus I sub 0 right here, these are all of the autonomous expenditures, autonomous consumption expenditure, autonomous investment expenditure, they're there. And this 1 over 1 minus b is called the multiplier. So this is called the simple multiplier. The simple multiplier gives us the increase in national income as a result of an increase in our autonomous expenditures. Okay, so for example, our autonomous expenditure increased by, let's say, 2%. The increase in national income will be 2% times the value of the multiplier. Okay, so that's how it's interpreted. All right, so there you have it. So you have the graph that gives us the equilibrium national income. And then we also have the mathematical expression right here that gives us the equilibrium national income, or equivalently equilibrium aggregate expenditure because of this condition. Okay. And in the next video, what I'm going to do is we're going to work on a numerical example. See you soon.